So hey guys, welcome back to the channel. Hope you all are doing well. This is Abhishek on the other side. If you haven't subscribed to my channel or if you are new to my channel, do subscribe to my channel and press the big fat bell icon in order to get the latest notification first. So without much further ado, let's start our today's video. I'm going to solve an important question, and the name of this question is count of smaller numbers after self. Now it is a high level question from LeetCode. The question states that we are given an integer array nums, and all we need to do is that we need to return a new counts array. So we need to return a counts array, right? And the property of this counts array is that now each of the elements of this count array represents the number of smaller elements which are to the right of that particular element. Now what does it mean? So if you take this example, so if you consider this 5, okay, now this 5, now the elements to the right of 5 are these elements, right? There is 2, 6 and 1, right? And the elements which are less than 5 is actually 2 and 1, okay, and hence the number of elements which are to the left, and the number of elements which are to the right and also they are smaller than 5 is actually 2, as you can see over here, right? So similarly for 2, the elements to the right of 2 is actually 6 and 1, right? And the element which is less than 2 is actually 1, so we have 1 as our output in that particular index, right? Next we have 6, and the element smaller to the right is 1, right? And it is also smaller than 6, and hence it is also 1. There is also one element, right, which is actually less than 6, and it is to the right of 6, okay. And next we have, when you come to 1, now there is no elements to the right of 1, right? So it is null, and hence we have 0, and hence the count is 0, right? So if you consider this example, so similarly for this example, as you can see over here, we have only one element, right? And since we have only one element, and hence it is 0, right? And if you take this example, so we have two elements, -1 and -1, okay. So now to the right of -1 we have only one element, that is -1, right? But -1 is not less than -1, right? So it is actually equals, right? And hence we have 0, count is 0. And similarly for -1, since there is no other elements to the right of -1, so the count is minus, so the count is 0, okay. I'm going to solve an important question, and the name of this question is count of smaller numbers after self. Now it is a high level question from LeetCode. The question states that we are given an integer array nums, and all we need to do is that we need to return a new counts array. So we need to return a counts array, right? And the property of this counts array is that now each of the elements of this count array represents the number of smaller elements which are to the right of that particular element. Now what does it mean? So if you take this example, so if you consider this 5, okay, now this 5, now the elements to the right of 5 are these elements, right? There is 2, 6 and 1, right? And the elements which are less than 5 is actually 2 and 1, okay. And hence the number of elements which are to the left, and the number of elements which are to the right and also they are smaller than 5 is actually 2, as you can see over here, right? So similarly for 2, the elements to the right of 2 is actually 6 and 1, right? And the element which is less than 2 is actually 1, so we have 1 as our output in that particular index, right? Next we have 6, and the element smaller to the right is 1, right? And it is also smaller than 6, and hence it is also 1. There is also one element, right, which is actually less than 6, and it is to the right of 6, okay. And next we have, when you come to 1, now there is no elements to the right of 1, right? So it is null, and hence we have 0, and hence the count is 0, right? So if you consider this example, so Similarly, for this example, as you can see over here, we have only one element, right? And since we have only one element, and hence it is 0, right? And if you take this example, so we have two elements, -1 and -1, okay? So now see, now to rewrite a -1, we have only one element, that is -1, right? But -1 is not less than -1, right? So it is actually equals, right? And hence we have 0, count is 0. And similarly for -1, since there is no other elements to write a -1, so the count is minus, so the count is 0, okay? So now let's see the algorithm for this code. So currently we are having four elements, right? 5, 2, 6 and 1. And the indexes for each of the elements is given as 0 to 3, right? Okay. Now what is going to be the brute force approach? Now the brute force approach is going to be that we're going to have two pointers. One will be I, which will continue to currently pointing to index 0, right? And another will be j, which will be pointing to I plus 1. Now since I is 0, so our j will be pointing to 1, okay, currently. So I is pointing to this element, and while our j is pointing to index 1, okay. Now we're going to check this condition, that is ARR of, so you can consider this array to be ARR, okay. So ARR of I, okay, and check whether our ARR of I is actually greater than ARR of j, right? Now if this condition satisfies, okay, then what will happen? Then we're gonna have a variable, so let's consider it to be s, right? Now initially our s is actually, or you can consider it to be count, okay. So let me just name it as c, okay. So initially the c is actually 0, okay, and we're gonna also have an array, right? So currently this array is empty, so let's consider an empty array, okay. So at first, now our I is at index 0, our j is at index 1, right? So we're going to check whether this 5 is actually greater than 2 according to this condition, right? Yes, it's true. Now when it's true, then we're going to increment this c by 1, so it will be 0, it will be 1, right? And next again we're going to increment this j, right, after. So now our j will be pointing to index 2, that is this element, right? So again it is going to check whether this 5 is actually greater than 6. No, it's false, right? Now since this condition fails, so we're not going to update this count variable. Next we're going to increment this j by 1. Now it is at point to index 3, right? Now again it is going to check whether this 5 is actually greater than 1. Yes, it's true. So we're going to increment our count variable to 2, and this j is also going to increment, okay, but since it has come to the end of the array, right? So we need to now would be requiring to increment I, right? But before incrementing I, we need to store this value of c. Now, so we'll be storing 2 to the first index of our answer array, right? Now next, once this 2 is stored, now we're going to increment I to 1, right? And then we're going to make this to 0, okay? And this our j will be pointing to I plus 1, right? That is, it's gonna be 2, okay. So now our I is currently pointing to this element, while our j is currently pointing to 6, okay. So again you're going to check whether 2 is greater than 6. No, it's false, right? So we're not going to update this or increment this count variable. Rather than we're going to increment the j by 1. So now our j is pointing to index 3, right? Now next it's going to check whether this 2 is greater than 1, right? Because the element present in index 2 is 1. So yes, it's true. So we're going to increment this by 1, it will be 1. So now since j reaches to the end, so we're going to store the value of c to our answer array. Next we're going to increment this I to 2, and now this j will be updated to I plus 1, that it is going to be 3, okay, and this count will be updated to 0, okay. Now next, now our I is currently pointing to index 2, while our j is currently pointing to index 3. Fine. Now we're going to check whether this 6 is actually greater than 1. Yes, it's true, right? Now since it is 2, so we're going to update this to 1, okay. So it will be storing 1, having 1, okay. Now next, as you can see that j has come to end, right? So again we're gonna increment this to 3. Now j will be I plus 1, but as you know that I plus 1 is 4, right? But fourth index is not present, right? So when our so when our so so we'll be moving our for loop from I equals to 0 to I equals to n minus 1. Okay, now where n is the size of the array. Okay, so over here the size of the array is nothing but 4, right? Okay, so we'll be moving our we'll be moving from 0 starting equals to 0, okay, to and to I less than n minus 1. Okay, okay, so this is the way we're gonna move. And coming out of the array we just need to append 0. Okay, and that will do our job, because last element will always be 0, right? Because there is no element on the right hand side, right, of the last element, right, of the array. So that's it. So that is the brute force approach. Now the time complexity will be n square, because we are actually traversing through this loop twice, right? And through this array twice. And while the space complexity will be big of n, because we actually have a array, right? Answer vector. Yeah, we actually have that, and for that we'll be requiring big of n. Right? So so now let's come to the optimal solution. So now for the optimal solution, we'll be considering the merge sort approach. Now, if you haven't watched my previous video on merge sort, where I have explained like what is merge sort and how to implement merge sort, then I would highly recommend you to watch the video first and then come back over here. So as you know that merge sort works on the principle of divide and conquer, right? So at first we're going to divide this whole array into two parts. Yeah, two hubs. Keep on dividing into this array, and then we're going to keep on dividing the sub arrays into two hubs, right? Until they are completely divided into individual sub arrays, right? Where each sub array contains only one element, right? And then we're going to merge this in sorted fashion, right? Yeah, merge the two sorted sub arrays into a more larger subarray. Okay, and that's the concept of merge sort. Okay, now let's see how using that concept we can actually solve this problem. So according to merge sort, we are going to at first divide this. Okay, so let's first divide this into subarrays. So we're going to divide it to, this will be, if we divide this, so it will be 5,2, and this is going to be 6,1, right? So let me just say how we are actually dividing. So we will be having a low pointer, okay, which will be currently pointing to index 0, and we will be having a high pointer, right? Okay, which will be currently pointing to index 3. Okay, so then we will be using a mid variable, and the formula for that is that mid will be equals to somewhat like low, okay, low plus high. Okay, so low plus high by 2. Okay, and then we will be considering the lower bound of it. Okay, and that's how we're going to find the mid. Okay, now if you see the low is currently our low is 0. Okay, and high is actually 3. So it will be nothing but 1.5, right? So if you consider the lower bound, it is actually will be 1, right? So we're going to consider two subarrays. Now one subarray will be ranging from low to mid. Okay, so this is our one subarray, and another subarray will be ranging from mid. So it will ranging from mid plus 1 to high. Okay, so this is how, now this is how we are actually forming the subareas, right? So as you can see that we have divided this into two sections, right? So 0 to 1, that is 5 and 2, and 2 to 3, that is 6 and 1, right? And then again we're gonna divide this into 2, so it will be 5, this will be 2, okay, after we have divided. And if we divide this component, so it will be 6, and this is going to be your 1, okay. So this is how we are actually dividing it, okay. Now once we have divided it, now now we cannot divide it any further, right? Because currently our low and high is both same, right? So now when our low and high becomes same, then we're gonna stop dividing, okay. Now we're gonna, so now we'll be performing the merging operation, right? That is, we're gonna merge these two sorted, right, subarrays into a larger sorted array, okay. So like how we're gonna do this? So now we're now using this, now in the merge function only we're gonna find count the elements which are actually smaller than 5, okay, and is on the right hand side of 5, okay. Now how we're gonna do this? At first we're gonna have a, so let's consider a answer, okay, answer vector or array you can consider, okay. So initially we have four elements, so it will be 0, so each of them will be 0, this will also be 0, now this will also be 0, right? Now since now when you sort the, now when you sort two elements, now their indices will get jumbled up, right? So in order to know like which element belongs to which index, it is recommendable to use the concept of at first you need to pair this element with another which is along with its index, like how. So over here we have 5, right? Now 5 should be paired with 0, okay. So in our code now, when we'll be coding, we'll be actually considering these elements as pairs, right? Pair of the value, and then we will be considering the indices, okay. Here we are not in the explanation, we are not actually considering it, but in the code we'll be considering them as pairs, okay. Fine. Now we'll be using this formula, like we'll be now currently we'll be having two pointers, that is I, which will be pointing to low, and j, which will be pointing to high. Now currently our low is nothing but 0, right? And our j is nothing but 1, because element 5 belongs to index 0 and element 2 belongs to index 1, right? As you can see, right? So now we'll be checking whether our AR of 5, okay, AR of I is actually greater than AR of j. Now if this condition satisfies, then we are going to increment this j by 1, so it will be 2, right? Now if our j, okay, now if our j is actually greater than the size of this right hand subarray, okay, exceeds the size of the right hand subarray, or it may happen that if this condition doesn't satisfy, then what we're gonna do, we need to perform this operation, that is we're gonna make answer of I, okay. Now what is this I? Now this I is nothing but the, so you can consider it to be index of, so you can I and D you can consider, okay. It will not be I, it will be I and D, okay. Now this I and D is nothing but the index of this element, that is original index, that is 0, okay. So plus equals to j minus mid, okay, mid minus 1, right? Now this is the formula we are going to use, right? Now if either of this condition doesn't satisfy, right? Now here as you can see that now this j has become out of the block, so we're going to use this formula, so we're going to store an answer of, So in answer of 0, right? Because the index of 5 is 0, right? So we're going to store 2 minus mid. Now what is this mid? Now if you now mid will be, that is 1 plus 0 plus 1 by 2, right? Which is nothing but 0, right? And then we're going to perform minus 1. Now it will be 1, right? So over here we're going to store 1, right? Now after we have done that, then we're going to merge this. Okay, merge this sorted array. Now it will become sorted, it will be 2 and this will be 5, right? Okay, fine. Now we're going to check, we need to merge these two sub arrays, right? So we're going to check whether, now currently our I will be, and now what is the index of 6 is 2, right? Now so in our original array, or this will be changed. Okay, this will change to 2 5 2 comma 5 comma 6 comma 1, right? Okay, so after we have merged, now this is going to be our array. Now again we need to merge this. Okay, before merging we need to check whether this and check this 6. Okay, now our I is 2 and our j is will be 3, right? Because our index of 1 is in this array is 3. Okay, so this is 2, this is 3. Now we're going to check whether our 6 is actually greater than 1, right? Yes, it is 2, right? Now since it's 2, so we're going to increment this j by 1, so j will be 4, right? So our j will be 4. Okay, now we cannot actually perform any other operation, right? Because it has only one element, and here also there's only one element, right? So we need to perform this operation, that is answer, right? So we're gonna, now this time we're gonna perform answer of 2, right? Because 6, we actually calculate it for 6, right? Because I is pointing to element 6 initially. Okay, so we're gonna use this formula, that is answer of 2 plus equals to j. What is j? J is 4. What is this mid? Now initially our I is 2, right? And our, okay, initially our low is 2 and our high is actually nothing but 3, right? So 2 plus 3 by 2, that is 2, right? So 4 minus 2 minus 1. Okay, so it is 1. So this will also gonna be 1. Okay, so then we need to merge this up. So this is gonna be 1 comma 6. Okay, so now let's merge these two sorted arrays, right? So currently our low is 0. Okay, and our high is nothing but 3, right? Okay, now what we're doing, we'll be actually finding the mid. So our mid will be nothing but 2. Sorry, a mid will be nothing but 1. Okay, so our I will be, now our I will be low, so it will be 0, and our j will be mid plus 1, that will be 2. Okay, fine. Now next we'll be checking whether this error of I, right? Now error of I is nothing but 2, right? So whether this 2 is actually greater than 1. Now yes, it's true. Now since it is true, so we'll be incrementing this j by 1, so it will be pointing to index 3, that's this element. Okay, so after we have sorted this, so our array will be something become like this. Okay, so it will be 2, this will be 5. Now this is gonna be yours 1, right? And this is gonna be 6. Okay, so this is how our array is going to look like. So if you want to, if you are wanting to know like how I am dividing and merging it, so please watch my previous video on merge sort, then you will understand it in a much better way. right? Okay, now would be now our j is pointing to index 3. Okay, that is this element. So we'll be checking whether this 2 is actually greater than 6. No. Now since this condition doesn't satisfy, so we'll be terminate out of the while loop. Okay. Now we'll run this command. So we'll be running like answer of now. Now what is the element in I? It is 2, right? And what is original index is 1. So as you can see over here, it is 1. Now since it is 1, so we'll be writing it is like this: the answer of 1 plus equals to, now what is this j? J is 3 and mid is nothing but 1, right? Sorry. So our j is 3, right? Yes. So our j is 3 and our mid is nothing but 1. Okay. So it will be 1. Okay. So now at the answer of 1 would be having 1, right? So this is gonna be 1, right? Now now we'll be running going including the value of I, because I is still left, right? So it will be incrementing the I to 1. Okay. So now I here of I is 5. Okay. So we're gonna check whether 5 is actually greater than 6. No. Now this condition also doesn't get satisfied, right? Now when this condition doesn't satisfy, again we're gonna run this command, same statement, that is error of, now what's the original index of 5? It is 0, right? So error of 0 plus equals to, what is this? This is nothing but 3, right? Mid is 1, this is also 1, right? So previously we have 1 already stored in error of 0, right? So actually we are adding 1 to it again. So this will be 2. Okay. And that's how we got our answer, 2, right? And finally this array will be sorted and we'll be getting 1, 2, 5 and 6. Now if you want to know like how we have performed a merge operation, I highly recommend to watch my previous video on merge sort. So now let's come to the time complexity. Now the time complexity for this algorithm will be nothing but big O of n log of n. Okay. And while this space complexity is big O of n, because we'll be using an extra space over here in order to store, right, from the sorted merging of array, we'll be requiring extra array. So that's it. Now let's go to the code for this algorithm. So now let's see the implementation of this algorithm. So at first what we have this vector right over here, and then we have this vector nums, right? So at first we are actually pairing it up. Now in the pair we are considering the two values. Now one is the element and another one is the, now this I is the index, origin index of that element. So if you consider this example, so let's say that we have elements like so we have elements like 5, 2, 6, 1, right? Now the way it will be stored is like this. So we'll be having 5, 0. Now 5 is the element and 0 is the index, right, of this. So this is of, so 5 is of index 0. So this is 0, this is 1, this is 2 and this is 3. Okay. So then we were having 2, 1, something like that. Okay. So in this way we are actually storing in pairwise in this vector v. Okay. So now let's see. So now then we are actually performing the merge sort, as you can see over here, right? So we have passed the arguments v0, nums of size of -1 and finally we have the answer vector. Now in the merge sort, we are actually performing the merge sort. So as you can see, so we have considered the mid, which is nothing but low plus high by 2. Then we are actually here in this two step, we are actually dividing the array into two sub arrays, right? So one ranges from low to mid, as you can see, low to mid, right? And another one ranges from mid plus 1 to high, okay? And then over here we are merging it. Now in the merge, now this in this function we are actually performing our actual operation, that is we are actually calculating the number of elements which is smaller than the particular element and is on the right hand side, okay? So at first we have L. Now L is nothing but the low and R, which is nothing but mid plus 1, okay? So actually we are running this loop from low to mid, and then we're actually checking whether our R, right, that is mid plus 1, as we have already discussed. Okay, now if these two conditions are satisfied, so if our R is actually less than equals to high, okay, and as I've already discussed, like v of I of first, right? Now first is nothing but the element, okay. So okay, now so if you consider this example, so 5 2 6 and 1, right? So after we have divided, right? So after we have divided into two parts, so it will be something like this will be 5 comma 2, okay, and this will be 6 comma 1, okay. Now this will be again divided into 5, and this will be 2, right? So here our low is actually 0 and our high is actually 1, right? So when we are performing a merge operation, so we are actually checking whether this 5 is actually greater than 2 by writing this statement, right? And once we see that the both of these conditions, so we are actually incrementing R. Now here we can consider R to be J in the algorithm we have already discussed, okay. So we are actually incrementing this index, right? The index which is currently pointing to mid plus 1, that is this element, right? Now then we are using the formula, that is answer of v of I of second. Now this v of I of second is nothing but the index of the origin array. So over here, if over here the v of I is nothing but is nothing but this element is pointing to this element, and its I of second means it is pointing to the index, right? Because as over here, so over here we can see we have actually stored the index, right? Element and plus the index, right? So v of I is actually of second actually pointing to index 0, right? So we're storing answer of 0 is plus equals to R minus mid minus 1, okay. We're using that formula. Now once this for coming out of this loop, okay, we are actually what we are doing, we are actually performing the merge operation, okay. So this is the portion where we are actually performing the merge operation. So at first we are actually checking like which element is so we're checking whether the element p of L of first is actually less than equals to p of R of first, right? If this condition is satisfied, then we are actually storing it in a vector or array, you can consider, which of size high minus low plus 1, right? And then similarly over here, and if this condition is satisfied, then we are storing v of R plus plus, okay. Now coming out of while loop, now if our L is still less than mid, then we are actually storing whatever elements are there, and if our R is less than high, then we are storing the remaining elements in our C array. And finally we are performing the merging over here, okay, merging the sorted array in our original vector v, and then we are returning, okay. So that is for the code. Now as you can see over here, now this since we are performing this merge operation, now this merge operation is taking big of n, okay, and this merge short, okay, and this divide, since we are dividing into two parts, keep on dividing into two parts, so it is taking log of n, okay. And since as a whole, So as a whole, this function is taking n log n, okay, and hence time complexity is n log n. And since over here we are using an extra array, so as you can see here also we are using extra array as v in order to store the element as well as the index. Over here also we have used extra array, that is c, right? So now let me just run this code. So as you can see it is accepted. So let's just submit it. Okay, it is getting submitted. See, it is accepted. So that's all for today. Thank you. So I hope that you like this video. If you like this video, do give a thumbs up to the video, share it with your friends, and subscribe to the channel and press that big fat bell icon in order to get the latest notification first. So that's all for today. I will see you in my next video.